In this video, we are going to review all the laws of exponents very quickly, and then we're going to look at two pretty complicated examples and see if we can use these laws to figure out how to simplify them. Okay, so I thought it'd be a good idea to just start by having you think about completing these rules instead of me just writing them all up at the beginning. So let's go through them, and hopefully you know what I'm going to write here, okay? A to the m times a to the n. That's going to be a to the what? All right, it's m plus n. If you don't have these memorized or at least know how to derive them, that's where you need to start, because if you don't know what to do in these situations, you're not going to know what to do to simplify the problems. All right, what if we're dividing here? Now I split this into two different cases, and in all honesty, I've got these numbered. Every book is going to have its own way of numbering them. They might use X's instead of A's. These numbers are not like you need to memorize rule number 2, rule number 3. I'm just numbering them so I can talk about them when we're doing them over here in examples. So if your book's a little different, don't worry about that, but most books have some variation of these rules here. All right, so when we're dividing with exponents, what do we do with the exponents? We subtract them. All right, so if m is bigger than n, you're going to do m minus n. And you could use this rule on all examples, but you might come up with a negative here. So I split it into a second case. What if n is bigger than m? It's going to be a little easier if you take n minus m. That'll keep things positive, n minus m. But you have to remember, since n is bigger than m, you have to put your answer in the denominator. All right, this is the power rule here. If I have a to a power, what do I do with these exponents? Hopefully you said multiply them. If I have a fraction to a power, I need to take both the numerator and the denominator to that power. If I have two things multiplied together to a power, I have to take both of those things to whatever power that is. And what about negative exponents? Our old friend negative exponents. Remember, negative exponent means reciprocal. So when you have a negative power, it means to take the reciprocal of a to that power. So you have to flip it over. Here I have a fraction to a negative exponent. So again, it means to take the reciprocal of a over b to that power, to the positive power, okay? And I just threw this one, a to the 0, anything to the 0 power is 1. And sometimes you see that and sometimes you don't. I don't know if we'll do one of those. Okay, let's go through two examples. Here we go. Let's start with this one. Example number 1. 5x to the negative 2, y, that whole thing to the negative third. And then I'm going to multiply that by 5x, y to the third, that whole thing to the fourth. Alrighty, so don't forget your old friend, the order of operations. You still need to obey the order of operations. So I have something to a power multiplied by something else to a power. And by the order of operations, I'm going to simplify the powers first. So what I'm really going to do is I'm going to think of simplifying this and simplifying that, and then I'll multiply them together. Okay, well, we've got multiple things going on here. I have a whole bunch of stuff to a power, so that kind of looks like rule number 5. Okay, I'm just going to jot that down. Rule number 5 says if I have a whole bunch of things multiplied together to a power, I have to take each of those things to that power. So I have to take 5 to the negative third, x to the negative 2 to the negative third, and y to the negative third. Alright, well, let's start that and see what we run into. So 5 to the negative third. Actually, I'm just going to write that as 5 to the negative third right now. I could think about how to do that using rule number 6, but I'm just going to leave it like that for a second. Alright, how do I take x to the negative second to the negative third? Well, that I'm going to use rule number 3. I have something to a power, and that tells me I have to multiply the exponents. Okay, so I'm just going to jot this down. I'm using rule number 3 also, and that tells me to take x to the negative 2 times negative 3, that would be positive 6. And then y to the negative 3. So that's the first part, all right? And that's going to get multiplied by this stuff to the 4th power. And I'm going to use pretty much the same rules again. So I have 5 to the 4th power. Oh, that looks like a 9. Let's try that again. 5 to the 4th power, x to the 4th power, and then I've got y to the 3rd to the 4th, so I have to multiply these. That's rule number 3, y to the 12th. Okay, so now I have a whole bunch of stuff multiplied together, which means I can rearrange it if I want to. You don't have to do this step, but I'm going to do it just to make clear exactly what's happening here. So I have 5 to the negative 3rd, and I'm going to multiply that by 5 to the 4th. Gosh darn it, why does that keep making it look like a 9? There we go. And then x to the 6th, and I have an x to the 4th, and I have a y to the negative 3rd, and a y to the 12th. That's just a commutative property. Okay, what rule am I going to use now if I want to take 5 to the negative 3rd times 5 to the 4th? That's rule number 1. 5 to the negative 3rd times 5 to the 4th. I'm going to add those exponents together. So that's going to be 5 to the negative 3 plus 4. Same thing with the x. It's going to be 6 plus 4. Same thing with the y. Now, you could use rule number 6 and do the reciprocal of this y to the negative 3rd. Same thing with the 5 to the negative 3rd. But if I can avoid that, I'm going to avoid it. And when I take negative 3 and add it to the 12, I'm going to have a positive exponent. So I'm not going to use rule number 6. I'm just going to use rule number 1. And that's one of the tough things about these problems is you have options. You could use any of these rules you want as long as you're applying them correctly. Notice up here 5 to the negative 3rd. I could have done 1 over 5 to the 3rd, and that would be 1 over 125. That would have been fine. But I chose not to do that because I saw I had a 5 to the 4th over here, and I knew I would be able to add these exponents together and just get 5, and that would make it easier. All right. Notice, I'll just put this part over here. If I would have done this out, which a lot of students do, all right, if they would do this out, that's that. 5 to the 4th power, if you multiply it on your calculator, 625. And that would be 1 over 125 times 625. And so if you do 625 divided by 125, you just get 5. But it's a lot easier to use rule number 1 and just add the exponents and not have to deal with all this. If you do it this way, though, you're still going to get the right answer. So it'll all work out as long as you're using the rules appropriately. So this is our final answer. We cannot simplify that anymore. That's it. So we used rule number 5 and rule number 3 for that one. Okay, let's try one more. Let's get rid of this. And we'll get rid of this. Okay, we're going to do one that has a big fraction. Okay, we're going to do x to the negative 4th, y squared, that whole thing to the 3rd, times x squared y to the negative 1 all over x y squared, that to the negative 3rd. Okay, so there's lots of ways to go here. If you want to give it a try, pause the video and go for it. Go ahead and then start the video again. Like I said, there's a lot of different ways to do this. I'm going to go ahead, and what I'm going to do is I'm going to use rule number 5 again. Because what I have here, rule number 5, I have multiple things to a power. I've got these two things to the 3rd, these two things to the negative 1, and these two things to the negative 3rd. So I'm just going to apply that exponent to each of those. And in doing that, when I take y squared to the 3rd, I'm going to have to use rule number 3 again. Maybe I'll do this problem 2 different ways. We'll see if we have time here. Okay, so when I do that, I have x to the negative 4 times 3. So negative 4 times 3 is negative 12. And then 2 times 3 is 6. You can keep this in parentheses if you want. You don't really need it though. And then I'll have x 2 times negative 1 is negative 2, and y to the negative 1 all over. And then I have x to the negative 3. And then y to the 2nd to the negative 3. So I multiply those and I get negative 6. Next thing I'm going to do is I am going to use rule number 1 to simplify the numerator. So in the numerator, I've got x to the negative 12 times y to the 6 times x to the second times y to the first. Now I do have these in parentheses, but it's all multiplication. So you really don't even need the parentheses there because everything's multiplied together. If I erase these parentheses, it's exactly the same thing. Okay? You can leave them if you want, but I just want to make that point. Okay, so in the denominator, I'm going to leave that the same, x to the negative third, y to the negative sixth. And in the numerator, I'm going to multiply x to the negative 12 times x to the negative 2. And that's rule number 1. X to the negative 12 times x to the negative 2. I add those exponents, and that's going to give me negative 12 plus negative 2 is negative 14. And I'm going to do the same thing with the y's. Y to the 6th times y to the negative 1. I'm going to add 6 plus negative 1, which is 5. Okay, we're almost done. I'm kind of out of room. I guess we're going to have to go over here. That's fine. Now I've got x to the negative 14 over x to the negative 3, and that looks like rule number 2. So we're going to use the quotient rule, which means we're going to subtract the exponents, and I could subtract the bigger one minus the smaller one, and that'll keep my exponents positive, so I'm going to do that. Okay, so for the x's, I've got an exponent of negative 14 and negative 3. Negative 3 is bigger than negative 14, so I'm going to put my answer on the bottom because that's where the negative 3 is. I mean negative 3 minus negative 14. And then the y's, I've got a 5 for an exponent and a negative 6. Oh, I kind of crossed out my problem there. Let's try that again. I have a 5 and a negative 6, and 5 is bigger than negative 6. So that means my y's are going to go in the numerator, and it's going to be 5 minus negative 6. Minus negative. Make sure you have minus negative, all right? So there my answer for my y's is going to be y to the 11th, and on the bottom I'm going to have x to the 11th. That was a coincidence. Minus a negative makes a plus, right? So negative 3 plus 14 is 11, and that is my answer. Crazy. All right, there's a lot going on here. That's as simple as I can get. Let me show you one other way to do that last step that some of you might like, since we never used Rule 6. Let's use Rule 6 to do the next step. I think some of you might like this better than subtracting the negatives, so use rule number 6. Let me erase this. So what you could do on this step right here is just get rid of all your negative exponents by moving anything that has a negative exponent. In other words, doing the reciprocal of anything that has a negative exponent. So for example, this x to the negative 14th, I'm going to take this guy and I'm going to move it to the bottom, and it's going to become x to the positive 14th. That's what this rule says. This x to the negative third, I'm going to move that to the top, and it's going to become x to the positive third. That y to the 5th is positive, so it stays there. Okay, this y to the negative 6th, I'm going to move that to the top, and it's going to become y to the positive 6. So if you did it that way, notice your next step, you would use rule number 1 to add the 5 plus the 6 and get y to the 11th. And then as far as the x's go, since you're dividing the x's, you would use rule number 2. And you would do 14 take away 3, and since the 14's bigger, it would go on the bottom, and you'd still get x to the 11th. Pretty cool, huh? So there you go. You'd get the same answer. It's really about deciding what rule you want to use and then using that rule and carrying out the plan. All right, so I'm going to go ahead and do this same problem again a little different way, just so you can see using the rules in a different way. If you're happy with what you've seen here and that works for you, then great. All right, I'm going to leave this answer here just to remind us what the answer was, and show that you'd get the same answer. So another way you could start this problem is by noticing that this whole thing's to the negative 1. All right, I'm going to leave this here because that whole thing's to the third, right? So this is to the negative 1. I could take this whole thing that's to the negative 1 and move it to the bottom and write it to the positive 1. So it would be x squared y to the positive 1. And then since this whole business right here is to the negative 3, I could move it to the top and I'd have xy squared and then change it to the positive 3. You could do that. Kind of gets rid of a lot of the negatives and then continue from there. So then if I took, now I'll take everything to the power, all right? So I got x to the negative 4th to the 3rd. I multiply those and get negative 12. I still have a negative exponent there. Y to the 2nd to the 3rd, multiply those, get y to the 6th. X to the 3rd is x to the 3rd. Y squared to the 3rd, multiply those and get y to the 6th. In the bottom, you just have it to the first power, so it's just x squared y. Okay, then we could simplify the numerator by adding these exponents together. So I have x to the negative 12 times x to the 3rd. So if I add those, I get x to the negative 9. And then I have y to the 6th. Let's use a different color. Y to the 6th times y to the 6th. So I'm going to add those. And that's going to give me y to the 12. This is looking like it's not going to come out the same as the other one, but it does. Okay, so now what do I have left? So for my x's, I have x to the negative 9th. I can either take 2 minus negative 9, or I could take this x to the negative 9 and move it down there, and it would become x to the positive 9 and get rid of that. And then add the 9 plus the 2 and get 11. And then as far as the y's go, you've got y to the 12th divided by y. Remember, this is y to the 1st. So by rule number 2, you're going to subtract 12 minus 1 and get y to the 11. So you'd get the same answer. This problem probably has, 10 different ways to do it and get to the right answer. So again, with these multi-step problems, just take one step at a time and make sure you're applying a specific rule to whatever changes that you're making in your problem.